Hello class, this is the video for section 5.1. We start in chapter 5, which talks about probability distributions. Okay, now we're talking about the distributions that deal with what? Discrete random variable. Remember we talked about these random variables. We have two kinds, the discrete and then continuous. Chapter 5 is the only chapter in this class that we will consider distributions, probability distribution for random variables. The rest after that, chapter 6, 7, and on, is all deals with what continuous what random variables. Okay. Now, the learning objectives are the following. At the end, we should be able to define discrete random variable and the probability, its probability distribution. Okay, determine when a potential probability distribution actually satisfies the necessary requirements. And given the probability distribution, we'll be able to compute the mean, the standard deviations, and the variance. Now, note that these are all parameters. They are not based on statistics. That is uses the population values, okay, numerical values, and then we use them to determine whether a value was significantly low or high. Okay, so random variables we know before is a variable that is typically represents by x that has a single numerical value determined by the chance for each outcome. Okay, so you have discrete random variable and then the continuous random variable. Okay, so for discrete random variable, we have what we call the probability distribution. They are the basic concepts of this. And the probability distribution, if it's a probability, then if you have any value for the random variable, we'll have a probability which is less than between 0 and 1 inclusive. Okay, so a probability distribution is defined as the description that gives the probability for each of the values of that random variable. It is often expressed in the format of a table, so like a formula or a graph. Okay, so these are the requirements. The following satisfy what we mean by a probability distribution. One, there is a numerical, not categorical, random variable x, and its number values are associated with what corresponding probabilities. That is one. Then if you find the sum of all those probabilities, you must get equal to 1. Or if you express in a percentage, that is 100%. Okay. And then, of course, for each of that random variable, the value, the probability is between 0 and then 1, as I mentioned before. Okay. So there are three requirements for a table to represent a probability distribution for a discrete random variable. Okay. All right. And then even for continuous random variable, right? Same thing. Okay. Now let's consider a coin, tossing a coin. Now I want to see how we can get this what I mean by the probability distribution. So if you toss it 2 times, okay, the following represents the random variable. We let x be the number of heads when we toss 2 coins. Okay, number of heads when we toss 2 coins. So meaning our focus is number of heads, not the tails. So when we toss the 2 coins, we count how many heads. Either both of them appear heads, or we have one tail, one head, or both tails. Okay, so we have to get a sample space for that and be able to determine what is its probability distribution. So the above x random variable, because it is numerical values depending on what chance, because when you toss it, that's by chance, that's probability. So the question is this a probability distribution? Okay, with that probability. Now, this is the x will represent the number of number of heads, okay, when we toss the 2 coins. So if you have tail, that means there's no head. That is why we have the 0. Now if you have one tail and one head, that's what we have the number of heads, only the number of heads that we are counting. And then 2 heads, and we have these probabilities. And I will explain in a minute why we have these probabilities in a minute. Okay. Now, this is what is happening, that the sample space is head, tail, head, and then tail. Okay, and then X still represents the number of heads from this. Now, if I look at the first element, head, there are two heads, right? So we can write a two heads, that's X is equal to 2. For the second and the third, we have X is equal to what, 1. And then the last, there's no heads, so that is what, that's 0. Now, usually we want to write it in a ascending order, not descending. So we write this as what, 0, 1, and 2. Okay, what is the probability? Out of these 4, there is one that has no heads. And so that is what, 1/4, or the same as 0.25. And then for one head, there are 2 of them, 2 out of 4, that is 2/4, that is 1/2. And so that is what, 0.50. And then 2 heads, there's only 1, that's also 1/4, or we have for 0.25. Now, as you can see, this is what, if you add these together, you get what, 1.00. That's why we have the probability, the sum of the P of what? P of X is equal to that. Okay, does it represent the probability distribution? Yes. Does it satisfy all the requirements? Yes. 1. Okay, the random variable has what, numerical values. Okay, that is the first. Now, the sum of the probabilities of the values of the random variable is equal to what? Is equal to 1. That's the second requirement. The third is that each of the values, in this case 0, 1, 2, has a probability which is what? Which is less than 1 or greater than what? Greater than 0. So the probability of X is that. Okay, so it satisfies all the 3 requirements that we talked about. Okay, so the question is that we can, once we have this probability, okay, distribution, we can have a graph, the histogram. Then the histogram will show us the distribution of it, which it will be the vertical axis will be the probabilities, okay, and then the horizontal axis will be the what, the random variable, in this case, the number of heads, X. Okay, so the probability distribution is similar to the relative frequency distribution that histogram that we did, but the vertical scale shows the probabilities, and then actual the instead of the relative frequency, that's the only difference. So from this probability distribution with the number of heads from 2 coins, this is the what? This is the histogram. And so the histogram, we call it what? Probability histogram, right? Okay, not just histogram, but it's what, the probability histogram. Okay, all right. So now the question is that this is a job interview mistakes, and I want to know whether this represents a probability distribution or not. In other words, does it satisfy the 3 requirements that we talked about? Okay, hiring managers were asked to identify the biggest mistakes that job applicants make during an interview, and the table below is based on their responses, based on data from our Adecco survey. Thus, the table below describe a probability distribution. Okay, now as you can see, this is your X, your random variable. Okay, random variable is what, inappropriate attire, being late, lack of eye contact, and checking. Now, the random variable must have numerical values. Okay, so because of that, just that one reason, okay, because of that, this is not a probability distribution. But let's go further. Now, for each of these are the probabilities, right? And then when we add everything, we get 1.57. Of course, the sum of the probabilities must be what? Okay, the sum of the probabilities of X must be equal to what? Is equal to 1. Must be equal to 1. And that is greater than what? 1. And so in this case, you will say this does not represent probability distribution. Okay, so I have the answer here. The solution, the table violates the first requirement because X is not a numerical random variable. For that reason, okay, and again, the values of X, as we said, they are not numbers. Again, it violates the second requirement. Okay, the sum of what the probability is what? More than 1. Okay, because the 3 requirements are not all satisfied, we say the table does not describe a probability distribution. Okay, so what are the parameters? Finding the mean, and and of the probability distribution. So remember that the probability distribution here, they describe what the population instead of a sample. So the values of mean, standard deviation are parameters, not statistics. Okay, so always remember that. Okay, the mean, variance, and deviations of a discrete probability distribution can be found with the following what formulas. Okay, that we will be talking about in there. So the mean is given by, see, the mean is denoted by the mu, okay, that is mu. And then the mu is a sum of what? X times what? The probability. Okay, this is the same as what we call the expected value. Remember what we did in chapter 3, where we found the mean and standard deviation and so on.
Okay.
But here, the mean is not given by the sum of x divided by n. It's a probability distribution. And so multiply each of the x by its corresponding probability, and then add all of them together. Okay, the variance, there are two formulas. Okay, one is what? After you get your mean, the mu, subtract from each of the x, square it, and multiply by what? The probability, the corresponding probability. Add everything. That gives me the variance. Or we can what? Square the x's, then multiply each of the square of the x's by the corresponding probabilities, sum everything up, then subtract what? The mean that you got, square of that, and then that gives you variance. And then the standard deviation, of course, is what? The square root of what? Square root of this expression here. Okay, this will be the standard deviation. Okay, so I'll have it in the next slide. But before I go further, this format is easier to understand, but the second one is easier to calculate it manually. And I'll calculate using StatCrunch manual and then also StatCrunch to show you what I mean by that. Okay, so like I said, the standard deviation is given by the square root of the variance, which gives me that formula. Okay, so here's an example. We'll be doing this homework number 6 using the StatCrunch in a minute. But here I have a table that describes the probability distribution for the number of heads, the one we just did. Okay, same problem. Now, in this time, we want to find the mean, the variance, and then the standard deviation. Okay, we have explained how we got this table. Okay, so we're going to calculate this together, find the mean, the variance, and the standard deviation. I'm going to use the what? For the standard deviation, I will use the second formula, and I will give you that in a minute. So A, okay, the mean is what? The sum of what? X times what? The probability of X. But everything we do, we need to what? To get a table. Okay, you have your X and probability of X. All right, so we have 0, 1, and 2. We have the probability of 0.25. This is 0.5, and that is 0.25. Okay, if you add everything, you get 1.00. Now, because of this expression here, you do what? X times the probability. So X times the probability of X. So 0 times 0.25 is 0. 1 times 0.15 is 0.5. And then 2 times 0.25 is 0.25. So when you add everything, you get what? 1.00. It's 0.5250, sorry. This is 0.50. Okay. Now, so what is the mean? Okay, the mean is what? As is given the sum of X times the probability of X, which in this case will be 1.00. Now the standard deviation, or let's do the variance. Okay, the variance is what? The sigma squared is given by, I'll use this formula, okay, X squared times, because it's easier to calculate this way, okay, minus the mu what? Mu squared. Now, because of this formula, I need to have a column that has what? That is what? X squared, because of this X squared here. Okay, let me change because of this X squared. And then I need to have the S squared times the probability, the corresponding probability. Okay, so let's square the x's. This is my X, So 0 squared is 0, 1 squared is 1, and 2 squared is what? Is 4. Okay, so the S squared times the probability. This is still 0. 0 times 0.25. 1 times 0.50 is 0.50. And then 4 times 0.25 is also 1. 1.0. Okay, so according to this formula, that is that we add this column, that gives us 1.50. Okay, so when you have this, would be 1.50 minus, okay, the mu, which is here, that's a square, that is 1.0 all squared. Now, when you evaluate this, that should be 1.50 minus 1, which is what? 0.5. And then the standard deviation, okay, the standard deviation, which is sigma, is the square root of what? The sigma square. So that is the square root of the answer we got, which is 0.50. And that should give us 0.7071. Okay. So if you run it to what? To say 2 decimal places or 1 decimal place, then that will be 0.7. Or say 1 decimal place or 0 or 2 will be what? 0.71. Okay. All right. So basically, that is what that will be using the formula this. Okay. Now I'm going to do problem number the homework problem. But before that, what's the interpretation of that? Okay, we got the mean, we got 1.0, that is 0.01 the heads. What does it mean? How do we interpret that? Okay, so it means that when tossing 2 coins, the mean that's expected number of heads is what? 1.0 heads. Okay, the variance is 0.5 heads, and then the standard deviation is 0.7 heads. Okay. Okay, so take note of that. That's the interpretation of that. Okay, now let's just further say that the expected value, which in this case the mean, for the number of heads means if we were to collect data on a large number of trials with 2 coins tossed in each trial, we expect to get a mean of what? 1.0 head. All right. Okay, so that's how we will interpret what? The mean, or the mean that expected. Okay. Now, further, let's identify the significance. What I mean by a value is what's significantly high or low. Okay. Remember, is using the range rule of thumb that we have been using. It is find what the 2 standard deviations. So if you have a numbers that is less than the mean minus 2 times sigma, it is what? Significantly what? Low. If it is more than or greater, it is significantly what? High. And then if it is in between, then there's no what? It's not significant. Okay. So remember this this chart very well. Okay, that gives us this diagram. All right. So now, okay. Okay, using the probabilities when we want to identify significant results using probabilities. So we can use the 2 standard deviation, or we call the range rule of thumb, okay, or we can use the probabilities. Now I want you to note this. When you use the probability to determine when results are significantly high or low, now note that if you find the probability of X or more and you compare it with what? 5%, okay? Or it depends on the questions, can tell you to use what? I mean, 1% or 5%, but generally we want to use what? 5%, okay? So the number of X of successes, in this case, the example we did the heads, okay, random variable X is significantly high if and only if the probability of X or more is less than 5%. On the other hand, it is what? Significantly low if the same what? The probability, the same 5%, the probability of X or fewer. Okay, so note that for high, it is X or more. And for what? Low, it is what? X or fewer. Okay, so let's look at this this example that is similar to homework number 7. Okay, now it says see below. Okay, we have given this proposal below describes the number of adults in groups of 5 who reported was sleepwalking. Okay, so the random variable X, okay, that's nobody out of 5, every group, you gather a group of 5 people, adults, and they'll ask them, and 0 means that out of 5, no one, reported sleepwalking. If you have 1, that's 1 out of the what? Out of the 5, 2, and then all the 5. And then they use that to find the relative frequencies, and it gives us what these are what we have. Now the question is find the probability of getting exactly 1 sleepwalking among the 5 adults. So if you have 5 adults, the X is what? 4. That probability is just what? So the probability of X equal to 4 is equal to 0.027. Or sometimes we can say that it is what? Just probability of 4, like that. And that is same as 0.227. So it depends on how you represent that. Okay. All right. Part 2 is that find the probability of getting 4 or more. Now notice that 4 or more sleepwalking adults among the 5. So if you go back to the table, 4 or more means that it is what? Exactly X equal to 4 or X equal to 5. So we're going to add these two probabilities together. Okay. So to solve this, this is what? The probability of what? X or more is what? The probability of what? X equal to 4 plus the probability what? X equal to what? 5. Or so this is 0.027 plus 0.02, and that gives us 0.02. No, so 02. This is 0.002. So that is 0.229. Okay. Or this is 2.9%. 2.9%. Let's write it well. That's the same as 2.9%. Okay. Now, part C, it said which probability is relevant. Okay, I want you to know which probability is relevant for determining whether 4 is significantly high number of sleepwalking among the 5 adults, the results from A or results from B. Okay, now I want you to know that significantly relevant, and then we found what? Getting 4 or more. Now, if the question has been 4 or fewer, the question part C will replace the high with low because of how we use that probability. Okay, the using probability to determine whether it is significantly high or low. Okay, so if you look at the table, let's go back. Okay, in computing what? 5, exactly X is equal to 5, it includes what? It includes the 4 adults who reported sleepwalking. All right. And so among the parts A and B, the part B will be more relevant. Okay. So here you say that since the probability of getting 5 sleepwalkers includes getting 4 sleepwalkers, the result of B is relevant probability. As simple as that. And then finally, the question is that is 4 significantly high number of sleepwalking number? Is it why or why not? Okay. So remember, to determine, you have to find the probability of X or more. Okay. This must be less than or equal to 0.05 if we use 5%. Okay. So that gives us what? The probability of 4 or more. Okay. This probability, as we go from part A, so sorry, part B is 0.01 0.29. Now, of course, this is what less than 0.05. So the answer is what? Yes. Okay. 4 is was significantly high. Is significantly what? High. Okay. All right. Now, let me do one problem. I don't know if I skipped that. I missed that. I was going to do one homework problem that I don't see. Okay. So let's do homework problem number 6. So I'm going to share with you. I'm going to stop sharing. That is using the StatCrunch to do okay, problem number 6. Homework problem number 6. Okay, so let me share my screen with you. All right, so this is the homework problem number 6, right? It said refer to the accompanying table, which describes the number of adults in groups of 5 who reported sleepwalking. Find the mean and the standard deviation for the number of sleepwalkers in that group of 5. Okay, so how do you find the mean? Okay, how do you find the mean? So this is this. You open this up and go to what? Open this in the StatCrunch. Okay. You open that in the StatCrunch. Give me a second. My StatCrunch is opening right now. Okay. All right. You should be seeing that. Okay. Now, I'm going to make some changes because the probability says P of X of X. When you put a StatCrunch, you put that as a formula, it's going to read as what P times what X of X. So I'm just going to delete that and just put what that's lowercase p. So they represent my probabilities. Okay. Then remember, I need to have what? On the columns that we did, I need to have what? X times the probability, S squared times the probability. Okay. So one way you can do this, can do them separately. Okay, or you can use the multiple expressions. So what you do is that go to open data and then compute. Okay, let me making sure that you've seen that. Okay, you're seeing that. Okay, you go to data, go to compute, and then multiple expressions. All right, so I have to give it a name. The first one is what? Let me call it or XP. That is X times the probability. And this is what? The lowercase x. Then I use the shift 8. That is a times the p. That is the first next column. That will give me the mean. The other one is what? X squared. So I'll use x. Just give it a name. I'll call it what? X squared p, meaning I have what? X squared. Okay. So shift 6. This is squared, or I can do x times x. Okay, s squared, then times what? Times the p. And then when you compute, it's going to create the two more, it's going to add 2 more columns. Okay, that gives you those. So as you can see, the x times the probability, corresponding probability is what? Is the third column. Then the s squared times the probability, corresponding probability is what? The fourth column. But I need the sum of these. Okay, the third column will give you the mean. The second column will be part of the formula to calculate the standard what? So the variance. Okay, so to get a sum, I go to statistics, summary statistics, and then columns. Then I need what? The sum of for these two. All right, then I go to the statistics and pick what? Just the sum. That's what I need and compute. All right, so the sum of what? X squared times the probability is what? 3.8. Okay, that one is 3.8. So 48, I said 3.8, 48, and then XP is what? 552. Okay, so let us get the mean and then what? The standard deviation this way. Okay, so let me share my PowerPoint again. All right, so what I'll do is that I'm just going to do it here. Okay, I'm just going to do it from what we got from from the start crunch. The mean is what? The sum of what? X times P of X. This is what we go 1.552. And then the variance, S squared, is the sum of X squared times the P of X minus mu of squared. Now, the sum of P of X, that's what we got 3.48 minus 1.552. Don't round this up, okay? So use your calculator and find 3.4. Let's evaluate that 3.448 minus 1.552 squared. Okay, when I evaluated, I got what? 1.077112. Okay, then the standard deviation, that which is what? The square root of that value, 1.00712, or the square root of the answer, so that I can find that straight away. So square root of the answer, okay, which gave me what? 1.0335. Okay, so if I go to and answer my question, go to the homework, I have the mean, I have the standard deviation, and then the variance. Okay, the mean is 1 point. Okay, the standard deviation is 1.0712. The variance, sorry, the standard deviation is what? 1.0335, to 2 decimal places. Okay, so let's go and enter our answers and make sure we got it right. Okay, so let me close it. Now the mean is that rounded to what? 1 decimal places. So this is be 1.6. Okay, and then the standard deviation is to 1 decimal places will be 1.0. Okay, 1.0. All right. Okay, so that is it. Okay, that is it. So we got that, and that actually ends this video. And thank you. I will be doing the 5.2 in a minute. Thank you.